100 News Lab with Channel 3 News. Good afternoon, I'm Caroline Davis, and this is your 1 p.m. Science News. Recently, science students across the campus of University of Maryland, Baltimore County, have been testing water sources on and nearby campus. Sources say they've been investigating the quality of water in response to outside forces. Our Channel 3 News research team went out to conduct their own experiments. They found that the stream by the athletic field and the stream by I-695 served as important sources of data here. Our team hypothesized that these two streams would be affected by different influences. We predicted that the athletic field stream would show high levels of nitrates and phosphates due to fertilizing, and the stream by I-695 would show high levels of dissolved oxygen and conductivity due to increased road salting. After this harsh winter, could the increased amount of salt on the road be enough to make these changes in the stream by I-695? Let's go live now to winter weatherman Tyler Spittle to tell us all about it.
Thanks, Caroline. Looking at our 4-day forecast, it appears that we'll be getting torrential rain on Tuesday and Wednesday, sunny skies and warm temps on Thursday, and it looks like we're going to be getting snow again, another whiteout on Friday. Expect to see road salt trucks all over for the next few days, depositing large quantities of salt. When the snow melts, it's possible that runoff from I-695 could be leaking its way into our streams. Back to you, Caroline.
Thanks, Tyler. So what does this mean for our research team? What kind of tests should they be performing out there in the field?
Well, Caroline, according to the New Hampshire Department of Environmental Sciences, road salt has been known to affect the water's salinity levels, which we measure using a conductivity test. Riedl's 2000 Estuary Lab tells us that when salt dissolves into water, it dissociates into ions, which then conduct electricity. So conductivity is a measure of the strength of the ions, which tells us basically how much salt is in the water.
Wow, that sounds electrifying. Thanks, Tyler. Now let's go over to Riva, our spring sports diva, to tell us more information about the athletic field. Over to you, Riva.
Thanks, Caroline. Well, I guess it's baseball season again, and you know what that means, don't you?
No, Riva, I have no idea. What does that mean?
That means it's time to fertilize. These fields are going to be greener than the lime I had in this morning's margarita. But that's not important. What is important is the effect that fertilizer is going to have on these nearby streams.
Riva, tell us more. What should our teams be looking for in these streams?
Well, Caroline, fertilizers increase levels of nitrates and phosphates, which can cause areas of eutrophication, a dead area in a water source where algae is abundant and no dissolved oxygen is available for other aquatic life forms.
So what should our team be doing out there, Riva?
They should be collecting full containers of water at each water source to test for dissolved oxygen, in addition to the water they collect for the nitrate and phosphate tests. The DO container must not have any extra air or the results of the experiment will be altered.
Okay, Riva, thanks for the tip. We'll check back with you at halftime to check the scores.
Wait, please don't go!
And that's all we've got for today, folks. Thank you for watching, and stay tuned for the 1:08 p.m. Science News for more information on this important topic, as well as more from Weatherman Tyler and Sports Diva Riva. I'm Caroline Davis, signing off. Hello, we're coming to you live from the Science 100 News Lab with Channel 3 News. Good afternoon, I'm Caroline Davis, and this is your 1:08 p.m. Science News. This afternoon, we're following up with our Channel 3 News research team to learn more about this important experiment and the water quality test being performed on UMBC's campus. We're here now live with Chief Analyst and Lead Scientist Rami Phillips to discuss more of the results of this experiment.
Thanks, Caroline. The experiment has been going great so far. We've completed our water collections and tests, and the lab is tabulating the results as we speak.
Rami, walk us through this experiment.
Sure thing, Caroline. In order to test our hypothesis that different potential runoff sources will affect the stream systems, and our prediction that the athletic field would show high levels of nitrates and phosphates, and the I-695 stream would show high levels of conductivity and dissolved oxygen, we collect our water samples from each source. Then we conducted all 4 tests on both water samples.
Very interesting. Did you have any way of controlling the experiment and keeping the results constant?
You bet we did. We controlled our experiment by making sure the same lab assistant completed each test, as in Lab Assistant Davis performed all the nitrate tests, Lab Assistants Kumar and Dempsey took charge of the conductivity and the phosphate test together, and Lab Assistant Spittle and Phillips handled all of the dissolved oxygen tests.
When did you collect these water samples?
We collected all of the water samples between 1 and 2 p.m. on Thursday, April 17, 2014.
Did you have any dependent or independent variables?
Our dependent variables were the test results, and our independent variables were the stream sites.
Do you think that we could get a sneak peek of the results?
We can give you the whole report. The results are just in.
Wonderful. Take it away.
Well, we found that by the stream by I-695 did in fact have higher levels of conductivity than the stream by the athletic field as we predicted. Additionally, dissolved oxygen levels were higher in the I-695 stream just as we thought they would be. The nitrate levels by the field were high as opposed to the low levels in the stream by the road. The phosphate levels were consistent throughout at 0.1 ppm.
So what does that mean?
Well, based off these results, while several of them were consistent with our hypothesis, the phosphate levels did not go as we predicted, and thus we had no choice but to reject our hypothesis.
Could you do anything differently in the future if you were to repeat the experiment?
You bet we could. We tested for these areas during a not so warm but wet time of the year. We could do these tests again in the winter and even in the warmer time of the year so that each test would be underway during the most relevant time of the year for each chemical to be deposited.
Wow, we sure all learned a lot today. That's all for this afternoon. Check back with your Channel 3 Science News team for more information about this important topic later tonight. This is Caroline Davis, signing off.